initiative is has numerous players and a lot of excitement. Um, I've been a CEO in the Valley forever and a VC for the last 15 years, and happy to see how we can make batteries dominate over hydrogen as we elect, electrify transportation.
Great.
Rick?
Rick, over to you.
All right. Hello. Good morning. Good afternoon. Good evening, everyone, depending on the time zone you guys are at. Rick Rajaie here. Been in the automotive business for about 30 years. Past 15 years of my career has been completely dedicated to xEV applications. In that capacity, of launched 30, 40, 50 different subsystems or complete vehicles, from mild hybrid to full hybrid to plug-in hybrid to battery electric vehicles. Currently, I work for a company called Goshen. We are a Chinese company with subsidiaries all around the world, in Asia, Europe, and in North America. VP of Engineering, responsible for design and manufacturing lithium-ion batteries for global OEMs. And before that, I brought a company called NIO to public. I was head of electrified powertrain, including batteries for NIO. And prior to that, I was global director of engineering for LG Chem, responsible for their North American division. So with that, turn it back to you.
Great, thank you both. So just diving into our first question here, and then we can go from there. Batteries are obviously more crucial than ever, but not just in transportation, EVs and scooters and all the rest, but also in energy infrastructure and all manner of appliances, right, that are coming up. Very curious to hear your take on just how the dynamics of battery innovation and manufacturing are going to be affected by these competing needs. This is such a tidal wave of demand. Looking forward, how do you guys think about, where there are going to be synergies in development, where there might be competition? How do you think about that outlook?
As you say, the battery industry is exploding. It's a multi-trillion-dollar industry here. I like to think about it sort of to help people get a feeling for what scaling means. And if you went back just a few years, in your personal life, where you looked around your house, you'd have less than a dozen batteries. You might have 4 in your drill and a couple in some other appliance. And even then, it was a multi-billion-dollar industry. And now, each person, if they have an electric scooter, has hundreds of cells. If they have an electric car, they have thousands of cells. And if their grid in their world is connected to the grid with any kind of battery storage, then there's tens of thousands of cells sort of backing up that household. So you've got, 5 orders of magnitude growth in your personal life of how many cells are in your world. And I think that takes a billion-dollar industry to, tens of trillions of dollars. And it also has the same impact on the supply chain and the manufacturing and the distribution and the amount of investment that goes into it. So it's a hot space because it's huge.
Yep, and do you anticipate that, the chemistries across all of those different applications, the form factors across all of those applications are obviously all different, right? When you think about, the folks who are developing these batteries and who are manufacturing these batteries, are those the same people or are those different people? How are you thinking about, as each of these applications grows individually, are we going to be able to see some kind of, shared benefit across all of them as things start to really get underway?
My view is the driver for innovation in the space has been the automotive sector, Tesla and Panasonic in particular. And even though it makes a lot of sense to do flow batteries or other kinds of batteries or other kinds of geometries for the grid, and for other applications. It's being driven by ferocious cost reduction and manufacturing productivity in the automotive sector. So I think everything is living on on those shoulders so far. Again, as they get bigger and bigger, it'll make sense to have, there will be startups that end up going off and taking a grid focus or, you know, specializing. But I think right now, um, even though there's lots of innovation work around solid state and other activities, it's I think it's being driven by the automobile and lithium ion for a while.
Got it. Rick, do you share that thought, or do you have a different take here?
I guess I'm going to relate to both of your questions very quickly. I'm not going to argue with Mark, but instead I agree with him. The first part of your question, yes, there is a technical and a logistics problem on reusing battery from automotive to retire them for energy grid, and we understand that. The second part of your question, who's leading it? Definitely auto for now. Unfortunately, our colleagues in ESS are looked at as a byproduct right now, but Mark is absolutely correct. Once the economy of scale is there, ESS guys are not going to reuse battery modules and battery cells from automotive products. Why? Because we are in the business of durable goods. We deal with a lot of environmental problems in our vehicles as opposed to a stationary device. They've soon realized that for cost cutting, they need to cut a lot of corners that we've implemented to make the product more robust, which is not really beneficial for them. So in future, I see that they are going to be more and more in control of their product and innovation.
Got it.
I think in time, the battery industry will, I mean, we understand that there's different requirements. The spider chart for the grid is different than the spider chart for the automobile. You don't need to do fast charge on the grid. You have to do fast charge on a bus. But right now, they're all being driven in the same direction. That'll separate over time.
Got it. Got it. So if I'm hearing you both correctly, it sounds like, there are tailwinds that exist, more generally for the entire industry, in large part kind of driven by just the demand from the automotive sector. But as things start to really gain momentum here, we're going to start seeing a lot more kind of more individual development. I think obviously that's already happening to a large extent in the energy storage space. But of course, the definition of a battery there and what batteries really look like is a little bit different. And I think that's a really interesting kind of differentiation to call out. In large part, we fixate on this idea of batteries being kind of your standard lithium ion battery, but battery tech is so much broader than that. And I think that you guys have alluded to that in both of your answers. In the case of mobility, yes, largely lithium ion, but there's a lot to be discussed in terms of where the world of battery can go in the next couple of years. But I'll dive into a second question here that does kind of tie into what you guys alluded to. The battery supply chain is still developing, and challenges exist at the raw material level, at the manufacturing level, kind of across the board, still a lot of hurdles to climb over here. What do you think is going to have to happen to ensure that batteries are manufactured at the rate that they're going to be needed in the future?
Rick, you want to go first?
Sure, sir. I give it a shot. So basically, whether we like it or not, there are legislations in place that are mandated. Sooner or later we have to follow, and those legislations are as black or white as they can get. And as part of these regional legislations, car/battery makers have to locally source their materials, including the raw materials for cell, which is very problematic. There are two things that us in the industry are considering: lobbying with the legislators, because they are the motivating factors behind it. Of course, the cost of transportation and logistics is another motivation factor, but the biggest motivation factor right now is the legislation. The first part of lobbying is we are trying to convince the governments that certain particular elements of our chemistry are not even available in the region that we plan to have our battery manufacturing plant. And still would like to be able to be legislated and homologate our products in that region and create saleable products to that region. So that's the first part, which is the lobbying. The second part is the technical part. Rest assured that we have a very good outlook of what is going to happen in 2025 as far as motivation. Try to prepare ourselves not to get pigeonholed by unavailability of materials. What it means is that we are thinking about other type of chemistries, for example, to enable us to continue the localization, get to the threshold that governments want. But rest assured, there are other elements that cannot be locally or even globally available beyond 2025. So we have a good outlook of what's going to happen. We try to shift the industry to make sure that we're not going to get pigeonholed.
Got it. If I could ask one clarifying question, who is the we that's doing the lobbying here and that design work?
Battery makers and car makers.
Cool. Yeah, I agree with you very much. I think the world has kind of seen that, we're trying to move away from a lot of more expensive inputs like cobalt into battery chemistries, and obviously some of the more problematic inputs to really try and with reduced cost, reduce risk, I think throughout the battery supply chain. And that those sorts of moves are being made across the board. Mark, I don't know if you agree or have something to add here, but would love to hear your take.
Yeah, I think the driver is cost and performance first, but there's also the overhanging issue of sort of the blood diamond, the blood cobalt issue from Africa. So I think there is a lot of pressure on developers to try to minimize the amount of cobalt. But cobalt's sort of got a special place on the periodic table, and you can't just willy-nilly get rid of it and still have the same performance. It has some pretty special characteristics. The other side of the supply chain that you were talking about, there's all these issues on the supply side, but there's also the whole end of life recycling side, which is finally starting to attract enough attention. We don't have old enough cars yet to have a huge quantity of off-take batteries, but that's going to come within the next 5 to 10 years. And guys like Redwood and others are sort of getting positioned to deal with that. But I think that's also an issue. I do think, or I hope, that we'll see not just recycling, but reuse. Because at the end of automotive recycling, those batteries are not dead by any means. And there may be ways to, put them back into either home use or grid use or other kinds of use. Or, just like used cars, they start in the US and they go downhill to Peru and Central America and all over the world. Maybe batteries will go downhill too.
Interesting point. On the subject of, the geography of this whole business and the way that these things are changing, I do want to kind of keep on that vein. Where do you guys actually think that battery production is going to happen in the future? I mean, in this kind of next era of fundamental production, it might be done much more globally than we had originally, always associated this industry a lot with kind of East Asian manufacturers. But obviously there's been tremendous growth in American and European battery manufacturers. It's no longer going to be necessarily the predomination of the Panasonics and SDIs and CATLs of the world. What do you guys actually see that picture looking like in the years going forward, and particularly with all of the dynamics, all the geopolitical dynamics happening between the United States and China? How do we actually see things shaping up on that front, in your opinion? Rick, let's start with you, and then we'll move to Mark.
Absolutely. So as far as motivation goes, I've come up with some examples of top-down and bottoms-up motivation, what's going to happen in the future, and give you a practical example of a certain company of how they handle it. So the top-down motivation is legislation and incentives. There are still a lot of governments under scrutiny from media that they're not fast enough in electrification, and they're putting agreements in place, JV or whatnot, with battery suppliers or even car makers to localize their products. So that's the top-down motivation. The bottoms up is that, as Mark stated a few minutes ago, when 7 years ago, 8 years ago, we got into this electrification business, the volume was not there. So it made sense for us to centralize our battery production and ship products. All right. For two reasons, that's not feasible now. Number one, the number of products in the ocean. Now we're talking about sometimes gigawatt hours of capacity, combining all of these companies together, that parts are in transportation. That's waste. Then on top of that, cost of transportation. And as you know, batteries need to be thermally conditioned to be transferred, and safety aspects of it. So putting a battery on a boat, send them from South Korea to North America 8 weeks later is not really practical anymore. Okay. Let me give you now a practical example of my former employer. When back in 2010, 2011, they only had one single factory in Ochang, South Korea. Later on, they expanded to China, then North America and the United States, in the state of Michigan, and then in Hungary. And all of their plans, localizations plans, were done back in 2018, 2019 timeframe. And you now hear they are actually expanding even further and further and further localized in the United States due to those motivation factors that I said. It makes economic sense for them to localize their products here.
Yeah, I think that's right. I guess the way I look at it, I used to work for BMW, and the, Germany GmbH can't afford to ship trillions of dollars to China or Korea in order to build their cars. Car companies are basically in the pickle of, they used to innovate on engines. Now they need to innovate on batteries in order to have a defensible and a financial strategy. And so, every country isn't going to become a major battery manufacturer, but all the major car manufacturers will become major instigators of battery manufacturing, accelerated perhaps by the military, because the military either won't or can't or doesn't want to buy batteries from the bad guys or even the other guys, and so they struggle with this. I was joking about this the other day, but a friend of mine is in charge of the Army's new battery initiative, and the good thing is they have one. The bad thing is it's only funded with $15 million, which clearly isn't going to, make much difference unless they scale that up by many orders of magnitude.
Right. Right. You made an interesting point there about, these automotive OEMs maybe becoming the next major battery manufacturers. Obviously, Tesla took that route. But folks like Volkswagen have been instrumental in the growth of battery companies like QuantumScape. They've been basically the kingmaker of Northvolt. I think they most recently ordered like $14 billion of batteries for the next 10 years from them. Who are the other players that you see stepping into the arena, particularly from the demand side, to potentially drive that next wave of major investment into battery technology? Are these guys both who are they, and are they going to be doing the work themselves? Are they going to be working with startups, in your opinion? Like, what is that future going to look like? How is that progress actually going to be made, and who's going to be doing the legwork there?
I don't think the auto companies need to own the battery manufacturing. they do need to lead on the technology, spend on the R&D, because they have the money and the driver to fund the R&D. You know, Tesla's basically owns, um, you know, Jeff Don's lab up in Canada, and's got a whole, you know, development program that just feeds that innovation. They choose to own the factories, but just as in the, you know, other tier one supply chain products, as long as VW and Hyundai and others can have supply, and you know, they don't necessarily need to own it, but they do need to own the technology and the know-how. Um, and I think, you know, we've been talking about it from the car perspective. There's going to be a whole new layer from the light aviation perspective where the performance is optimized for weight rather than other kinds of performance, and those might diverge over time as well.
Rick, what's your thought here?
I think really it's a business case. I think Mark is absolutely correct. We are focused on cars only. Car makers have gradually realized the value chain of an electrified vehicle, and many companies like Ford and General Motors, even a decade ago, they decided to maintain the know-how in-house, and hence the reason they design and manufacture their own batteries. I strongly believe that there are the leaders of the industry, similar to Tesla, are going to get into more and more value chain. They are going to have their minds. They're going to be in control of value chain, which goes back to one of your previous questions. They don't want to get pushed and pulled by the material suppliers. They want to have the upper hand. Furthermore, if you look at the costed BOM of an electrified powertrain, you realize that as a car maker, you're not going to make any profit anymore. You have to have a very good vertical integration and hands-on into your entire electrified powertrain, including the battery. Otherwise, you just give the profit to your suppliers rather than you take the profit home. And I honestly see it working with many OEMs globally. I see more than 10 OEMs as we speak are getting into the cell technology. Now, whether they acquire a company and or they are basically self-developing their own know-how in hope and anticipation that one day they can be self-sufficient. Best example, LG and General Motors. I see the fast followers. I worked with other OEMs that they only purchase battery packs as an end item. Now they are buying battery modules as an end item. I had customers that purchase battery modules as an end item. Now they're buying cells as an end item. That's an indication for me that everybody in the field is expecting to tap into more and more of this business.
Got it. And from your understanding of kind of how everybody is designing their packs, are these packs, in your opinion, starting to become more similar over the course of time? Or are they starting to look more and more different as different companies start to look for various form factors of the cells, various power requirements? You know, what is that trend looking like from your perspective?
I guess there are two approaches here. As I stated during my previous question, one of the reasons that car makers are getting into the battery business because they understand the inefficiencies of buying a battery as an end item. You've heard a lot of terms as cell to pack or cell to chassis. These are custom-made solutions that OEMs receive the cells from the suppliers and integrate these cells into their chassis. They want to get rid of inefficiency of battery enclosure or whatever inefficiencies that are included into my battery modules. So that goes to one direction, that everything is going to be custom made from one hand, and from the other hand, OEMs are going to be responsible for battery design and integration. And whether or not they want to get into sales business or not, that's debatable. On the other hand, I still see fast followers. They either don't have the know-how or this is not their core competency, or they don't have the volume to justify all of the upfront costs. So what they do is that they still are taking baby steps Hence, they are more in favor of standardization. VDA standards, for example, in Europe, which is very dominant. I still see a lot of OEMs adopting that VDA standardized battery modules and pack, even for products beyond 2025. They have a tougher time to change their non-electrified platform around the electrified platform. They just don't have the volumes. Hence, they're stuck with that old platform. They just want to morph the electrified powertrain into it. Hence, they want to be the cost down, complexity down, risk down. They don't want a custom-made solution for them.
Yeah, I think that makes a lot of sense, right? There are the companies that do have this kind of core capability in battery design at the system level, and kind of from day one have been thinking about their vehicles as electric vehicles. And then there's the GMs of the world, right, who are thinking about, okay, we're going to have to electrify, our entire portfolio of vehicles over the next couple of years. They're going to need a very different type of solution from suppliers, from the supply base. In terms of, just the innovation opportunities that exist, it sounds to me like there's actually quite a bit that can still be done outside of these OEMs and be sold into them, even for the next decade, really, as they get up to speed with kind of the direction that the whole industry is going, if I'm hearing you right.
I think you're right that it's, there's tons of innovation available in the battery space for the next, not just for the next decade, but for several generations of battery materials, battery technology improvements. But at the same time, I think if we look back over the last decade, we've seen a lot of harmonization of the approach. If you remember the early electric cars, some people had air cooled like Nissan, some people had water cooled, some people hooked it into the air conditioning cooling system. Some were completely, married to minimizing the number of connections, and so they wanted big brick cells, not understanding that that's a stupid idea for thermal reasons, and so they ended up, with different approaches in Gen 1. By the time they go to Gen 2, everybody's got small cells, everybody's got active cooling, everybody's got a skateboard, everybody goes, I got to copy Tesla or I'm left behind. And so, basically we're seeing that happen. And it's just like, in other tier 1 products, somebody's got the right idea, everybody goes there because you can't afford not to, or you get left behind. And if cars today are competing on range, 10% more range, which sounds trivial, can make a car sell or not sell. If the Audi's got 280 miles and the Ford's got 320 miles, you can't sell the Audi.
Mm-hmm. Yep. And that actually brings me to our last question, which hopefully we can spend our last 4 minutes here just kind of talking through, which is, there are these couple of innovations that are going to be crucial to make sure that this technology set gets to where it needs to be in order to make sure that the EV revolution is enabled and continues to move forward at the rate that it needs to move forward in order to avoid climate impacts that I think everybody's acutely aware of, right? And Bill Gates actually made the claim in his book, How to Avoid a Climate Disaster, that we can only improve on batteries by a factor of 3, but not by a factor of 50. I'm curious, number one, do you agree with that statement? Or do you think that in fact, there can be revolutionary change in battery technology over the next couple of years? And if you do think so, what are those technologies to your mind, or those trends that you're looking at, which could potentially unlock that potential? I'll give it to Rick first, and then we'll go forward from there.
Sure. We talked about problem statement before. material availability. And so that's a huge motivation for us and the urgency for us engineers to come up with solutions. My crystal ball says that industry is going to be very heavy on cobalt-free chemistries for the next 5 to 6 years. I do not see cobalt-based chemistries to go away. According to Mark, we still have applications that we need the performance, we need the power. So they're not going to go away, but the market shift from, let's say, 30, 40% LFP to 70% NCM is going to be completely shifted to 15% NCM/NCA, and then the rest LFP. Mm-hmm. And that's just a mid time frame enhancement. I sincerely believe that solid state is the future. If you asked me that question a year ago, I would have said no. Things have been significantly changed over the past year. I've seen samples of products that they work. So customers at the end of the day want a product that is safe, a product that has the reasonable amount of range, the product that is cost competitive, and it looks beautiful at the end of the day. If the total cost of ownership is justified for customers, they really don't care if their vehicle is equipped with LFP or fuel cell or solid state. They really don't care. So us engineers, what I'm trying to say is that we try to really translate that voice of customer and give them a product that gives them the range, gives them the cost competitiveness. It looks nice and it is cost competitive. That's basically what we're going to do in the next few years, and that's going to be the focus for the next few years.
Gotcha. So to you, it's really more to do with just how much can you reduce the cost of batteries rather than how much can you improve the performance of them, just because that's really where things need to go in terms of making sure that the EVs are actually purchasable for people. Yeah, that makes sense.
Yeah.
When you look at the last decade or so, 15 years, batteries have come down between cost reduction and performance improvement. They've sort of been on a roughly 9 or 10% learning curve. And that's gotten harder and harder to achieve, but we've managed to achieve it. There's a few situations, China and some of the really low cost vehicles are even going back, I'll call it back, to, lithium iron phosphate, because it's just cheap. But others, I think, are really pushing the limits of getting all the electrodes thin and all the layers thin and everything, sort of all the inert stuff as light and small and cheap as possible, so you can pack the cell with the maximum amount of sort of active material. But after that, I think Bill Gates is right. Once you hit some asymptotes for, that's the theoretical energy density, you're done. And that's not the same. You can't take a battery to the energy density of gasoline, but you don't need to be super successful.
Right. Great. I think that's actually a great note to end on. And Howard, anything else that you wanted to add here before we turn it back over to the wider audience?
Sorry, I'm afraid we're out of time, but it's been a great discussion, and it's a great lead into our next panel, which is about China, which is like the biggest battery producer in the world still. But I wanted to thank you, AJ, for doing a great job of moderating, keeping these guys talking. And Mark and Rick, thank you for your insightful and expert comments. Thank you for a great panel.
Yeah, thank you all. Really appreciate it.